Hi everyone, today I want to talk to you about graphing quadratic functions. So this is one method that we can use to graph quadratics when you're given the equation. You'll see here that I have three things written down. AOS for axis of symmetry, the vertex, and the y-intercept. We already know how to find the axis of symmetry and the vertex, so let's go ahead and do that first. Remember that the axis of symmetry, we're doing x equals negative b over 2a. And so if I go ahead and do that, I have negative b, which is negative 6, over 2 times 1. So a negative times a negative is positive, so that's going to be 6 over 2. So x is going to equal 3. So that's my axis of symmetry. And now to find the vertex, remember we just plug that back into the original equation. So I have y is equal to 3 squared minus 6 times 3 plus 5. Remember that we can just do that in our calculator. Let me pull that up. So in our calculator we're just doing parentheses 3 squared minus 6 times 3 plus 5. And that gives us negative 4. Okay, so y is negative 4. So our vertex then is at 3, negative 4. So let's go ahead and put those two things on our graph. Let's start with our axis of symmetry. So we know that that will be, I'll make that a dotted line, and that's going to be right here on 3. Okay, so that's our axis of symmetry, and our vertex is at 3, negative 4. So remember, your vertex is right on your axis of symmetry. So here's going to be my vertex. That's the only information I have so far, but there is one other piece that I can find, and that's the y-intercept. To find the y-intercept, all we're doing is plugging 0 in for x, because the y-intercept is on the y-axis, and everywhere on the y-axis x is 0. So if I plug 0 in for x, I get 0 squared minus 6 times 0 plus 5. So that would give me 0 minus 0 plus 5 is just going to be 5. So my y-intercept is going to happen at 0, 5. So that would be right here. Now remember yesterday we said that that axis of symmetry cuts our parabola in half. So everything is symmetrical on either side of that axis of symmetry. So now I have this one point that's on my parabola. I know that I'm 3 units away from the axis of symmetry. So if I go 3 units away on the other side, I know that that is also going to be a point on my parabola. Okay, so far I have 3 points. I probably would pick one more just to make sure I have the shape correct. So I might pick a point between that y-intercept and that axis of symmetry. So maybe I'll just pick 1. And I'll plug x equals 1 into my equation. So if I do 1, let's see, where's my equation? Right here. So 1 squared minus 6 times 1 plus 5. And that would be 0. Okay, so if I plug 1 in for x, right? If I plug 1 in for x, I get 0 for y. So I go to 1, 0. So I know that's a point on my graph. Okay, and because I'm 2 units away from the axis of symmetry with that point, then I'm going to go 2 units away on the other side as well. So by plotting the vertex, okay, by finding the vertex, by finding the y-intercept that gives me 2 points actually, and then picking one more point gives me another 2 points. So I get a total of 5 points just from doing that work. And now I can easily just sketch in my graph. Remember that you don't just connect the dots in a straight line. Remember the parabola is curved. So you want it to be a nice smooth curve. Oops. like so, arrows on the end, and there's a sketch of your parabola. Okay, so find your axis of symmetry, your vertex first, put those on your graph. Find your y-intercept by plugging 0 in for x, put that on your graph, and then find the point that's symmetrical to that, right? So I was 3 units away, so I go 3 units on the other side of the axis of symmetry. Then pick one more x value. Pick something small that is easy to plug in. You can do that right in your calculator. Plot that point, figure out how far you are from the axis of symmetry, and then plot another one on the other side, and then sketch in your graph. Okay, there's 3 problems exactly like this, very similar to this, on your assignment for today. Hopefully this video will help you, and we'll see you next time. Thanks, everyone.